Okay, so let's get started. So we're going to look at the Pythagorean theorem, and you guys have seen this before. So some of you totally know what to do with Pythagoras and others don't. So I'm going to be saying very similar things to your other teachers, but you know what? Maybe you just don't get it. Maybe you want a different explanation. So you're going to use this device. It's called Google. And if you just type in Pythagoras, guess what? It just comes up because it's so important. So you can search for any topic that we look at. There's Wikipedia, pretty boring. There's a whole bunch of other stuff. This one, Khan Academy, he's got a whole website full of educational videos. Tons of math, tons of science. It's like a free tutor, right? So go to it. I would highly recommend Khan Academy. Watch his videos. I'll just show you a little example. Right? So it gives you an alternate explanation. Sometimes I like what he does. Sometimes it's a little too college stuff. Oh, it's working this morning, and I'm plugged in. Where's my volume?
Theorem. And it deals with right triangles. So a right triangle is a triangle that has a 90-degree angle in it. So the way I drew it right here, this is our 90-degree angle. If you've never seen a 90-degree angle before, the way to think about it is if this side goes straight left to right, this side goes straight up and down. These sides are perpendicular, or the angle between them is 90 degrees, or it is a right angle. And the Pythagorean theorem tells us that if we're dealing with a right triangle, let me write that down. If we're dealing with a right triangle, not a wrong triangle, if we're dealing with a right triangle, which is a triangle that has a right angle or a 90-degree angle in it, then the relationship between their sides is this. So if this side is A, this side is B, and this side is C, and remember, the C that we're dealing with right here is the side opposite the 90-degree angle. It's important to keep track of which side is which. The Pythagorean theorem tells us that if and only if this is a right triangle, then A squared plus B squared is going to be equal to C squared. And we can use this information. If we know two of these, we can then use this theorem, this formula, to solve for the third. And I'll give you one more piece of terminology here. This long side, the side that is the longest side of our right triangle, the side that is opposite of our right angle, this right here, it's C in this example, this is called a hypotenuse. Hypotenuse, very fancy word for a very simple idea. The longest side of a right triangle, the side that is opposite the 90-degree angle, is called the hypotenuse. Now that we know the Pythagorean theorem, let's actually use it, because it's one thing to know something, but it's a lot more fun to use it. So let's have the following right triangle. Let me draw a little bit neater than that. The following right triangle. So right triangle, this side over here has length 9, this side over here has length 7. And my question is, what is this side over here? Maybe we'll call that C. Well, C in this case, once again, it is the hypotenuse, it is the longest side. So we know that the sum of the squares of the other side is going to be equal to C squared. So by the Pythagorean theorem, 9 squared plus 7 squared is going to be equal to C squared.
Answer is yes.
9 squared is 81, plus 7 squared is 49. 80 plus 40 is...
Guy's voice is annoying. Kind of reminds me of Mr. Bell's. Okay, so you guys kind of get the idea here with Khan Academy is a great resource. If you're stuck on stuff, it's the same stuff, man. It's like it's not reinventing the wheel. go have a look. Go search some information, figure it out. You don't need a teacher telling you the same stuff over and over again that you're not learning. You go and try and learn it yourself. It's going to help you make it easier to understand. So let's talk about Pythagoras' theory. A little bit more detail. What Pythagoras actually did is when he had this right triangle, add 90 degrees please. When he had that triangle, he used the sides and made a square. So here's the square, and the square is a dimension of c by c, which gives it the area c squared. So c squared is actually representing the area of a square using that side length. And he did the same thing with all the other two. So this side length a, he made a square that was a by a, and he found the area of a squared. And then he made this square b by b, and he found the area of it, and the area of that square was b squared. So when we were doing the square stuff, he actually played around with the numbers, and he found this, totally discovered it, that when you add the areas of the squares, it equals the area of the square. Okay. Now I like to write it as c squared equals. So c squared equals a squared plus b squared. And then c squared equals a number. And then to undo the square, you have to square root. And you can't do it to one side. Algebra says keep it equal, do it to both sides. So then you get c equals the square root of whatever answer you got from doing the addition of the squares. Now there's a way to check. The way to check is by knowing that this c, which is your hypotenuse, must be something. What must the hypotenuse be? We saw it on the Khan Academy video. What must it be? Exactly. It must be the longest side. So if you find side that's longer than the longest side, you did it wrong. For example, if C was 10, but then you found B to be 12, is that possible? No. You know you screwed up, so you got to go back and change it. Instead of adding, you should have subtracted. Okay? So if you get anything longer than C, you did it wrong. Please, please check your questions, because if you check it, you can never get it wrong then. Ever. Okay? Now, let's say we have a squared plus b squared equals c squared. We want to know what one of the legs are. Just to let you know, these both are legs, and you can change them. Whereas c squared is your hypotenuse and cannot change. But these two can switch. Okay? So what if you want to move b squared to the other side, so a squared was by itself? How would you move plus b squared? A squared minus b squared. So you would have 2a squared. No, you're not answering my question, Josh. The question is, how do you move b squared? Why minus it? So you want to do what? Why did you choose a minus? Exactly. So what I'm trying to get at, Josh, is you want to do the opposite of the plus. That's why it cancels. So these are gone, and you're left with a squared equals c squared minus b squared. Use this formula when you're trying to find a leg. And again, a and b can be in different spots. That's fine. Okay, but it's important to see that when you're trying to find a leg, you will do a subtraction from c squared. So c squared's first, and you're subtracting the other square. Okay? What's your check? How do you know if you did it right? How do you know if you did it right? We just talked about it. It's that simple, guys. Like, if C squared is the longest, you know you did it right. If it's not, you know you screwed it up. You gotta go back and change it. Okay? All right. Let's read the first question, please. Read the first question. Underline the important stuff. Go. Okay, so what you should have underlined is diagonal, soccer field, 100 by 50. So what kind of shape do we have? Soccer field, 100 by 50. Sorry? Someone said it. I don't know who it was. Rectangle. So please draw that. Drawing diagrams will help you with your problem solving. Now what else do we need to draw in our diagram? The diagonal, which goes from one corner to the other. You could draw it in this orientation, or you could draw it in this orientation. It doesn't matter. Okay, you just choose one. Now where would you put the 100 meters? Would you put it right here? And then the 50 there? Why not? What's wrong with that? Yeah, the 100 is the longest, and you put it on the short side. That does not make sense. So it makes sense that the longest side's the longest measurement, the shortest side's the shortest measurement. Rectangles have 90-degree corners. So what letter can we label this diagonal with? Josh? That's a pretty long label. It is the hypotenuse. You can use, yep. C squared, yep. What else? What does the hypotenuse start with? You can put an H. What else? Not C squared, that would be wrong. Just C. Okay, or you could put an X. All right, let's just call it C because you guys want to keep it simple. Start by writing the formula. I like to do it over on the side, otherwise you're probably going to run out of room. C squared equals A squared plus B squared. That's your formula. Start there. Then substitute in. It doesn't matter which one's A and which one's B. 50 squared plus 100 squared. C squared equals 2500 plus 100 and 2 more zeros. So C squared equals 12500. Now what? So I just squared the numbers, I add them together. How do I get rid of the squared part on C squared? Yep. Square roots. Okay, so I do the opposite of squaring, I square root. Do the opposite, keep it equal. So C equals the square root of 12500. Now you go to your calculator. Don't use your calculator till the very end. If you need your calculator for the middle part, no problem. Please show all your work. Now round to the nearest tenth. And please try starting calculator so you know if you're using it properly. And once you get your answer, you should come up with a short, what's the short sentence? Pinto? Awesome. Diagonal is 111.8 meters. Well done. Okay. Just a quick little sentence. Okay, read question number 2. Once you get that written down, underline the important stuff. Go. Okay, so square, area, perimeter. You have a square, whoops, not a square, not a rectangle, which is 404.41. So the formula is A equals S squared. You know the area is 4.41, so substitute in for the letter A. And that equals S squared. Not the number 5, but the letter S. So what's the opposite? How do we undo squaring? The opposite of squaring is square rooting. So square root both sides, and you can get the letter S is square root 4.41. Now I wish I could write underneath here, but I can't. Okay, so I'm just going to then go to my calculator and find that answer. Please make sure you're doing this on your calculator so you know if you can get the right answer too. So I get 2.1. Is that the final answer? No. Okay, that's just the side length, but we want the perimeter. So perimeter of a square is s plus s plus s plus s. What's the short form of that? Yeah, s times 4, but usually with algebra, we write the 4 first, so 4 times s, or 4s. Okay? So if a number is in front of a letter, it assumes multiplication. So I have p equals 4 times s, p equals 4s, same thing. So then I substitute in p equals 4 times 2.1, and I can find my perimeter real simply by timesing by 4, and equals 8.4. Quick little sentence, perimeter is 8.4 meters. Okay? Nice and simple. There's a lot of math involved there, a lot of little stuff. Okay, we want you guys thinking. Okay, read the next. Okay, so this one is interesting. We have a rectangular room, so you should underline rectangle, the measurements, and square tiles. So the area of the floor means area of the rectangle. Length times width. Area equals 5 times 3. Area equals 15 meters. So what we have is we have 15 meters covered by 375 tiles. Now what we want to figure out is if it's 1 meter, how many tiles? So what we do is we can set up proportions, okay, equivalent fractions. So how would we go from 15 meters down to 1 meter? Divide by 15. So what would we have to do to the bottom of the fraction then? Divide by 15. So that allows us to find how many tiles in 1 meter. This fraction could have been flipped too, that's fine. Okay? So we go 375, divide by 15, and we get 25 tiles. So in 1 meter squared, you have 25 tiles. So I'm just going to write that on top, 25 tiles, 1 meter squared. Doesn't really matter how I write the fraction. Let's draw a little diagram then. Here's a square, 1 meter by 1 meter. How can we fit 25 tiles in there? Think of squares. How would that work? 25 tiles in a square. "25 tiles in a square." What would be the side length if it would fit in there perfectly? Valerie? 5 and 5, exactly. So we go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 5 tiles in 1 meter. 5 tiles in 1 meter. So how can we go from 5 tiles down to 1 tile? Now 1 meter, we got to break that into smaller units. So what can we write down instead of 1 meter that would be a bit smaller unit? Yes, Josh? Brilliant. So 100 centimeters in 1 meter. So don't say anything. Please solve this. This is going to be just like question B now. Going from 5 tiles to 1 tile. So divide by 5 and you get 1. Divide by 5 and you get 20 centimeters. So the tiles are 20 centimeters by 20 centimeters. Okay, so 20 centimeters is the edge length. So, what kind of assumptions have we made with this rectangular room and with these tiles and with our measurements and stuff? That's not an assumption, that'd be a calculation. Okay. But I'm talking about thinking about how a room gets tiled. Yes, you're right. Why don't you look on the floor and think about how this room would get tiled? This one right here. Pardon me? Sorry? One after the other? Okay. Yeah, you're right. One after the other. Look on the floor, please. What do you guys think about? You get tiled. All right. This is a rectangular room, so would it? Straight across? You haven't looked at, why don't you look on the floor right beside you? What do you notice about it? Look behind you on the floor. What do you notice about it?
I noticed some.
Yes, what?
Some of them are like half or quarter, third tiles.
Brilliant! He actually looked on the floor, right? The tiles, we're assuming that these tiles fit perfectly in the room. That's extremely rare when you're tiling a floor. So you got to go from a problem, mathematical problem, to what's the real world solution? What does it really look like? What's that big thing in the corner? So do you think there's tiles underneath that? No. Look at this cupboard. Would you pull that off the wall and rip it off the wall to tile underneath it? No. Okay, so often you're not doing that. Sometimes you are, sometimes you aren't. But you're going to assume that there's nothing like a big pole going down from the ceiling. You're assuming that this is a perfect rectangular room in a perfect world. Not likely. Okay, so that's just some of the things you'd assume. It's a perfect rectangular room. There's no obstacles to tile around that you wouldn't have to cut any tiles. You quit chirping back there. You just either say it or don't say it. Okay? Exactly. Okay. Number 4. Have a read, please. Go. Okay, so the measurements from A to C is 975. A to B is 375. She has to go all the way around this triangle. So we actually have to figure out that measurement as well. What do we want to call that measurement? B, X, whatever you want. Let's call it little b. So b squared equals c squared, a squared. What should you do? Should you add to make something longer than the hypotenuse? No, never. So we know the hypotenuse is 975, so we should be subtracting. Okay, so b squared equals 975 squared minus 375 squared. B squared equals what? Oops, clear. So b squared equals 810000. How do we get rid of squaring? How do we undo it? Do the opposite, which is square root. Algebra says to do it both sides of the equal sign. So b equals square root 900. Okay. So this side here is 900 meters. Now you can find the perimeter. So in a triangle, we simply add all three sides. And this will tell us the total distance that she paddled. So she paddled total distance of 2250 meters. Okay. So for the time is going to equal her distance divided by her speed. So time is going to equal 2250 meters divided by her speed of 2 meters per second. So it's going to be 1125 seconds. Is that a good answer? No. Why is that not a good answer? Yeah, it's a whole pile of seconds, and there are a lot more seconds than simply 60 seconds. So what do you think we should do with that? Put it into minutes and leftover seconds. You guys want to know the easy way? Write it as a fraction to figure out how many groups of 60 are in there. What's your answer, Josh? Good. So he didn't leave his answer as a decimal minutes. So there's 18 whole groups, and then there's 45 seconds left over. So as a mixed fraction, you can get your minutes, which is 18, and 45 seconds, which is left over. Okay. Now, a lot of you, if you have an ABC button on your calculator will convert that for you. And so you can see the whole entire answer. Okay, so what are some of the assumptions with this question?